Our catapult, named Seraphios, was built during 2 days. The measurements were taken by measuring wood planks of 50 centimeters length. We start shrinking the size of the wood planks that will be part of the base. We started shrinking the size of the wood planks that will be part of the base first, in order to get the form of a rectangle, which ended having a measure of 38 centimeters width and 91 centimeters long. Once we have those measures, we take them to calculate a good size for the middle part of the catapult and the arm. The last one ended having measure of a. Once we had those measures, we take them to calculate a good size for the middle part of the catapult and the arm. The last one ended having a measure of 75 centimeters long. The bar that connects the arm with the rest of the catapult was made with copper tube and steel rod. This part is connected with some metal nuts. To assemble the catapult, we use screws and metal nails, and for the basket, we use a flower pot tied up with some balloons.
También lo mismo al principio. Sí, otra vez. In the x direction, we have time that is 0.84 seconds. In x, it's 6.5 meters, and we don't have the velocity final in x. So in the y direction, we have always the time that is the same, 0.84 seconds. Acceleration due to gravity as minus 9.81 meters per second squared. Velocity final is 0 meters per second, and we have to know the velocity initial. In the x direction, we have time that is 0.84 seconds, and x 6.5. We decompose. Okay. We decompose in the x direction, and we keep. We have the first shot with this magnitude, so we have to decompose it in the x direction, and we. Now that we have the initial velocity, we can calculate velocity in y. That is with the formula initial velocity times sine of theta. We put the data and it's 8.8472 meters per second times sine of 29. And the resultant is 4.7892 meters per second. Now that we have the origin velocity, we can calculate the velocity origin in y. That is with the formula velocity origin times sine of theta. We put the data and it's 9.3337 meters per second times sine of 29. Now that we have the velocity in x, we can know the origin velocity. That is by knowing the formula Vx equals Vo times cosine of theta. We split the formula and we get velocity origin is equal velocity in x over cosine of theta. We put the data and it's 7.7380 meters per second over cosine of 29. That is 8.8472 meters per second. We have to. ¿Qué digo? ¿Es que velocidad in x?
Sí, velocity in x.
To calculate the velocity in x, we have the formula distance over time. That is equal to 6.5 meters over 0.84 seconds. It gives us 7.7380 meters per second.
In the second shot, we have to do the same procedure we done in the first shot. We only change the data. The new data is time equal to 0.81 seconds and distance in x, which is equal to 7.08 meters. So our new results are in velocity of x, which is equal to 8.7407 meters over second. Initial velocity, which is equal to 9.9937 meters over second. Initial velocity in y, which is equal to 4.8450 meters over seconds. The value of capital T that we use to solve maximum height in this problem is equal to 0.4938 seconds, and the total value of maximum height is 1.6162 meters.
A ver, otra vez maximum height.
Maximum height is 1.6162 meters.
That is 1.3576 meters. To get the exact value, we add the height of the catapult, which is 0.42. So the final operation is 0.9376 plus 0.42, that is 1.3560. So finally, to get the maximum height, we use the formula y equals velocity initial in y minus velocity final in y over 2 times t. But the velocity final in y is 0, so we get velocity initial in y over 2 times t. So the data is 4.7892 meters per second over 2 times times 40.4372 seconds. The resultant is 0.9376 meters in height. Y en vez de 5.
Yeah.
In the third shot, we use the same procedure as the first shot. We change the data, time equal to 8.84 seconds, and distance in x, which is equal to 6.33 meters. So our new result is equal to 7.5357 meters per second. Initial velocity, which is equal to 8.6159 meters per second. Initial velocity in y, which is equal to 4.1771 meters per second. The value of capital T that we use to solve maximum height in this problem is 0.4258 seconds, and the total value in maximum height is 1.3093 meters.
Known as the velocity of x.
Velocity of x.